Hey guys, welcome back to Get Good, the video series where I tell you why you suck and how you can improve at coding interviews. Well, actually that's not entirely true up until this point. I've pretty much just told you why you suck. Don't worry, today we're going to change that, I promise. I'm going to tell you how to actually study, and this is going to be the first step you're going to take in order to improve. Keep in mind, this is not the part of the video series where we talk about doing the interview problems themselves. This is just solely how to study. We will get to that in future videos and the systems I use myself on how to approach and troubleshoot problems. But today, we will only focus on helping you get started. After all, what is battle without good preparation? This will cover the basic template for how I studied each topic I was confronted with and how I chose to organize the coding questions I practiced on. Now, this template boils down to 3 steps, and while there is some wiggle room for the steps in practice in between, there really isn't much, simply because the core idea behind this methodology is consistency and efficiency. I hope by now I have convinced you that you need to be able to perform quickly and with high accuracy under any condition for these interviews. Humans are creatures of habit, so it's very important that you train one habit at a time and get very good at it. And the best way to do this is to repeat a process over and over and over again until you have reached autonomous proficiency. And that all starts here, with how you improve. So, welcome to the coding interview. You suck. Now, before I continue, I know some of you are just looking for the what books should I read or what subscriptions I should pay for. Okay, let me give you the very quick 10-second rundown. My recommendations are Grokking the Coding Interview, henceforth known as Grokking, and Elements of Programming Interview, henceforth known as EPI. I'll have links to both of those in the description down below. They are by far the best interview material prep that I have seen. And no, this guide is not actually sponsored by any of these books or courses. But at least hear me out before you shell out money for any resources, including the ones I've just recommended. Now, there are some prerequisites. First, we want to get a good source of knowledge. Well, what constitutes a good source of knowledge? A good source of knowledge means a book or a problem that trains the same algorithm, data structure, or idea over and over again. You will basically be repeating the exact same skeleton of code every single time until you puke. For instance, there should be a lot of problems in a row that practice your ability to iterate over 2 sorted arrays. There should be a lot of problems in a row dedicated to a binary search, and so on. This is opposed to having LeetCode only. LeetCode doesn't really train you in one specific area. Rather, it's just a collection of questions that jump from topic to topic. Having all these pre-curated in a centralized location will save you a lot of time because you won't be out hunting the internet, wondering what you should be focusing on. This is where I highly recommend purchasing either a book or a course. And don't worry too much about the price. Most reasonable books and resources cost less than $100. And you'll make that back in a single hour once you land your dream job anyway. And so this is why I recommend Grokking. Grokking provides a lot of common coding patterns and compilers for these patterns so you can test the problems, not just with pencil and paper, but also by submitting code to make sure you're actually right. EPI just fills in the gaps, but they do a very good job of showing what the naive solution is and what the optimal solution is. For instance, let's look at this problem from EPI. Computing the spiral ordering of a 2D array. Write a program which takes an n by n 2D array and returns the spiral ordering of the array. Hit that pause button if you want to try this problem out for yourself first. I'll leave a screenshot of the solution up here for you, but I'll quickly go over it. What I like about this is that they not only acknowledge the naive solution in a clear and consistent way, they also explain what it takes to get to an optimal solution as well. In this particular case, they explain that the naive solution is correct, but it's not clean and it's actually very difficult to write and to troubleshoot. The first attempt at a more clean solution is to be able to make the code uniform and simple, where you take the first n-1 elements of the top row, then at the far right, then at the bottom, then the left, and you continue to parse inwards. But we can actually get even more compact and cleaner than this. We can generalize this into a traversal and turn step, where the condition for when we turn is whether or not we're out of bounds or visiting a square that we have already seen. We will turn in the order right, down, left, and up. And once we put this together, this just becomes a very simple for loop. So, as you can see, the book does a very good job at not only showing you how to get the solutions, but also to improve them in ways a simple LeetCode submission cannot. Second, as you study, you must focus on one topic at a time. You will pick a topic to specialize in over the next few days. This can be trees, hash maps, graphs, whatever. You should adjust this if you feel very confident at it, or extend the time if you don't, because each of these topics come with their own set of patterns that are used specifically for them. The number of these patterns can vary. For most books, these are usually split up by chapters, and for courses, these are usually split up by modules. I would say if you want to get comprehensive coverage of all the topics, just follow the order the book or course presents them in. Just stick with one topic for a few days. Third, you must be willing to study the right way. So, what is the right way? There are two dimensions to this. First, it means thinking about every step you take to find the naive solution and why you take that step. This means also not spamming the LeetCode submission machine with a bunch of crappy code. Once you have a naive solution, you should also be able to get the optimal one. If you cannot get the optimal one, you can at least look at the optimal solution, understand it, and understand what it takes to go from your naive solution to the optimal one. This should also include what characteristics of the problem to look at. Once you've done that, you shouldn't just memorize the solution, but you should also look at how you could have done the problem faster, looking back at the past decisions you took in order to get to your current solution and how you can get more efficient at it. Because again, this interview is a measure of how efficient you are at problem solving. As a supplement to this, you can compare yourself to someone else who has solved the exact same problem, and you can look at how they solved it. Maybe they solved it faster. If so, how can you copy that thinking? What steps did they take in order to solve it? Can you predict what steps they're going to do and how they will approach the problem? Are they doing the problem faster than you? All these are questions where if the person is doing better than you along these axes, you should just copy him and learn from him. I'll cover copying other people's thinking in another video because I feel this is actually secondary to actually studying the material itself. This is more of a nice to have, and I can go into extensive analysis about this. But for now, I'll recommend Abrar Hussein's channel and just simply watching what he does. Alright, now let's get into the actual meat of the video. We're going to cover how to actually look at a pattern or look at some topic and learn it. So the first step is to understand an algorithm and data structure to autonomous proficiency. This means that you should automatically be able to write out the skeleton of whatever algorithm you're focusing on. Now, there are many algorithms out there that you won't see in your college textbook and are really only useful for the interview. But your job at this current moment is to master them anyway, such that it becomes second nature. Unless your interview is scheduled for 2 months in advance or more, you really don't have to worry about retaining the information you just learned. Once you've mastered it, your subconscious will retain it long enough for you to actually do well in the interview, provided you properly practice, of course. The implication is that the algorithms themselves should become second nature. Writing a binary search or a depth first search should be a breeze, and you should be able to do it on command without really thinking. Second, you should derive rules and hints of when to use them. You probably think of algorithms as a way of performing an action, that they are just fancy steps to follow like a cooking recipe in order to get an answer. You are probably memorizing an algorithm, how to implement it, and its runtime and space complexities. That's pretty much backwards in terms of order of operations. Think of an algorithm as a way of getting a desired outcome based on a series of preconditions. Once you meet these preconditions, you can apply the algorithm to get the desired outcome. Dijkstra's algorithm is a way of finding the shortest path between two nodes of a graph. This means that if you see an undirected graph where the graph is positively weighted and you want the shortest path between two nodes, then you can apply Dijkstra's algorithm. But you must ensure that all these conditions are met first. Data structures can be thought of the exact same way. They are ways of organizing information efficiently based on certain preconditions and rarely should ever be dedicated to a single data type. Now, why do we think of things this way? The reason why we think of things this way is so that way it allows us to assemble solutions from the ground up using very simple properties. That way, if someone asks you to justify your decision, for instance, why do you use merge sort over a quick sort, you will be able to understand and explain why. You'll be able to pick apart the characteristics of the problem, and you can match it to a particular algorithm or pattern. As you practice these algorithms over and over and over again, you should actively seek to understand the preconditions, how to write each algorithm, and the result that you will get. The implication is that the preconditions are the most important part, not the algorithm itself. The algorithm is important and you should be able to do it enough times to write it off the top of your head, But it is so much easier to check these conditions than to throw random data structures and algorithms at a problem. For instance, in the case of Dijkstra's algorithm, you can either check if a graph is positively weighted and if you need to find the shortest path by asking the interviewer or parsing down the problem, which takes roughly about, 15 seconds. Or you can be inefficient and randomly try Dijkstra's algorithm at a graph and waste 5 minutes when you don't even know what you're looking at. Furthermore, some of these rules can be optimizations on top of naive solutions. Because every algorithm and data structure has a different operation and runtime, they can be used in lieu of each other when the conditions are right. But it's about being able to see optimizations on top of optimizations that get you there. So what I mean by this is once you have the ability to strip down a problem into its characteristics, then you can build your naive solution. Then you need to strip down that naive solution down into its bare components again in order to build your optimal solution, or at least a solution that is more optimal. Now the third step is to be able to backtest those preconditions. As you master more and more techniques, you might end up with the wrong technique because some of the preconditions and rules clash with older techniques you learned. Let's qualify this phenomena in a 4-stage competency chart. You will start off at 1, where you are trying to figure out what the algorithm or data structure is about and how or why you should use it. You will come up with a few rules that will be your hints to decide whether or not to use the data structure or algorithm. Then you'll try it out against your current problem, and then the next problem, and the next problem, and the next problem. As you do this, you'll become more and more proficient at it. This is going from 1 to 4 at the chart. But your biggest problem won't be going from 1 to 4. You'll be doing that several times over and over again with each new algorithm you learn. The biggest problem will be going from 4 to 1. As you learn the nuances and patterns of each algorithm, you might end up learning the wrong thing, or you might learn an incomplete set of preconditions. Or one of your preconditions could be totally wrong. In short, the conditions you choose for each data structure or algorithm can interfere with each other. While this incorrect knowledge might work for now, it will clash with future preconditions. If you rely on the wrong insight, that will make you apply the wrong pattern the wrong way or at the wrong time. That's fine. What is more important is that you can course correct very quickly, especially during the actual interview. The only way you actually course correct quickly is by encountering this confusion in practice. If you think you've come up with a new precondition, backtest it against the last 5 or so patterns that you've done. And you do this by looking at the problems that you've already done. Usually the problems are grouped by data structures or algorithms that they are applied to, so it exposes you to more problems where you might actually make that mistake. Make sure it doesn't confuse you or make you mistake the usage of one algorithm for another. More importantly, make sure that the set of preconditions that you use for the algorithm can consistently lead you to the right answer. And now the fourth step is to understand what happens when you improperly apply the algorithm. As you backtest, make sure you understand actually what is happening and why. Understand what the implications are for misusing the algorithm, because sometimes that's actually what you want. There are only a finite amount of manipulations that you can actually do on these data structures or algorithms, and really, sometimes these mistakes you make are actual legitimate problems in and of themselves. So once you've actually seen the problem or you've made the mistake, it becomes so much easier to actually deal with it because you've already dealt with it before. The point I'm trying to make here is that you should be making mistakes and misusing the techniques so that you learn. You need to try them against different problems because those mistakes are part of the process as well. So you should embrace it. Let's recap. To study, you will need 2 things: a good source of knowledge that drills one topic at a time, and to be able to study one topic at a time for an extended period of time. So the 3 steps are: first, to understand a data structure or algorithm to autonomous proficiency, where you can write it out off the top of your head. The second is to derive rules and hints of when to use them. The third is to backtest those preconditions against anything else that you have learned. Usually, this is where you start to try other similar problems to the one you are trying, or previous problems that you have already solved. The fourth is to understand what actually happens when you improperly apply the algorithm. In the next video, I'll be demonstrating an example of how I would do this. So stick around. If you like this video, please like and subscribe, and I'll see you all in the next one.